Okay. So this is the last problem from the hard bucket. So we are given with a sorted array, and we are given with another variable k, and we have to like find the kth smallest fraction. So we have to create a fraction in a such a way that for every p less than q in the list, the fraction will be p by q. So let's start with this example, and we are provided with a array, and it has these values. So as we can see that one is smaller than 2, one is smaller than 3, one is smaller than 5. So one of our fractions will be 1 by 2, 1 by 3, 1 by 5. Again, there will be a fraction 2 by 3, and one fraction will be 3 by 5. So in all the fractions, we have to get the, if we will sort these fractions, then we have to find the kth index out of it, like over here. So we have 1, 2, 3. So the 2 by 5 is the kth number. So we have to return the third fraction, that is 2 by 5. So I guess the question is clear. So is there any doubt regarding the problem statement?
No, there's no doubt.
Okay, so anyone who tried solving this question or who has some approach how to solve this?
I was thinking like to start with some like binary search approach because it's a sorted thing.
Yeah, right. So we can go with the binary search, but how will you approach this, like the binary search?
Like uh, we need to check a middle thing, and if that um, like there would be something I haven't tried like, but it's sticking to my mind that if there is something middle, we need to check if that middle um, is lesser than the like it's lesser than uh, it will be our one of the case. Otherwise we need to like jump somewhere, like moving, we need to move forward until unless our the fraction which we are getting is lesser than the mid. Like for example, if we start from 1, and here our middle is like maybe 0.5, I think so. So,
So how you will be getting your search space? Like what will be our search space in this?
sorry.
Like from which range? Like what will be the range of search in this binary search? Like the first and the start, the first and the last.
Oh yeah. So I was thinking our range, because it's a fraction, so our range should be between 0 to 1.
Yeah.
Yeah. So if the middle is 0.5, then, and any element which is the fraction which if we are getting um, greater than um, greater than 0.5, then we'll be like, for example, my I is at this position 0 at and j is also at 0, then this will be 1 is greater than 0.5, then we'll be moving j like this, how until unless um, our fraction is whatever the fraction we are having is smaller than the 0.5, until unless that would be one of our fraction, which we can say that that would be our p and q. And how, I am not sure when we need to traverse all the loops, like where we need to stop it. Maybe we need to stop until unless we reach that k value.
Yeah, but for that, I guess we have to traverse everything and see. Like,
Sonia,
not it.
could you like please give us a dry run or so?
Yeah, let me then.
Yeah, Yes, sure.
Do you want to share your screen?
Yeah.
Okay.
So here we have something like
1, 2, 3, 5.
1, 2, 3, 5. And if this is our zeroth position, 1 is at zeroth position, and so our range is between 0 to 1. And so for so like we can say that low is 0 and high is 1. And here our middle is like zero point 0.5. And if we start from if we start from this 0 position, um, like until or unless um, our our j is, for example, less than n, which is n is the number of elements in an array. uh, Size of the array. And then like if this a like if I start from the same position, 0, I is 0 and j is 0, then then which means that 1 is greater than zero point 0.5, which is not. So we'll move j, and now our j is at one position, and now it's 1 by 2, and 1 by 2 uh, is now 1 by 2 is not greater than zero point 0.5, like it is equal. So now our p and q, we need to make our p and q for that, and now our p and q is 1 by 2. One p is 1 and q is 2. You getting how I have these two p and q? Like something, I'm not sure about it, something would be like that. And the main part is like we need to check k. And if now our k is still how we reach to the k, I think we need to take one more variable where which is like n minus j would be our the count. And if, like for example, one variable is if n minus j, and whatever the n is like 4 minus 2, and if our k is something like less than the count, then we need to be moving like then we need to change our low and high in that case, like something like that. I'm not sure about this, if you're getting my point.
Got somewhat, like not completely.
Yeah, because I'm not sure about it. So I'm thinking like some brute force would, like brute for binary search would work, but how it should work, that's the one thing.
Like the first intuition that I got when I saw the question is, I thought of a heap data structure,
Exactly.
but
That's what we need to do.
but the thing is, like if you use heap data structure, then I might lose the fractions. So like I have to return the I and j, right? So the
Yeah.
p and q value, right? So I think the in Python I can use tuple for this, but I have no idea about C++ and other language. So in Python I can create a tuple of the uh, fractions, like with p by q, then and the raised to part I can assign p and q values, and then I can heapify it, like we can push into a heap, and then I can get the kth value.
Basically, we could do this like just finding the fractions, pushing it into a minimum heap, and then finding the p by q, the prime numbers from fraction is not a big task. But even if we don't want to do that and we want to use an extra space, we could use a hash set or a hash map for that. For in case, let's just store q versus the fraction and multiply the fraction with q to get p. So we're having p and q both, and like We're just directly getting the answer here. We're not required to do it so much things.
Yeah,
That would
exactly.
be the extra space, but if we go for a binary search, like I'm just talking like if we know some approach in binary search, then it would be log n.
Yeah, your point is true that binary search is log n, but the basic part is you'll have to go like n square, go for n square to find the fractions firstly, and then the work we are doing, adding it to a heap and then doing upify and everything, that's only O of n. So in any case, our maximum time complexity will be order of n square, and yours will be the same too. The overall time complexity, if you do it by binary search, it could be a bit less, but as you see the constraints, it's just the array length is 2000. So we directly get that we have to traverse n square, and we have to use the like basic intuition we get. We study for finding these kinds of questions. I guess so.
Hmm. But still, I am thinking, well, why it is n square in here?
In any case, you'll be you'll be for in case you did for this case, what you do did was you for one, you increased your j, right?
Mm-hmm.
Here also, so let's consider a case of 5. Now your mid will be 2.5, and in any case you'll have to increase your j, but you'll have to increase your j till 5, and still at the point you add 5, you're not greater than your mid. Here also you are at 1 to add 5 divided by 5, that's 1. Okay, somewhere in between, like 3 by 5. So in this case also you are traversing n minus 1 star n. So
Mm-hmm.
basically you are traversing n square here too,
Okay. Okay. Yeah, I
if
haven't
I'm
thought
clear with
about
it.
that. Mm.
Yeah, so I guess the heap thing will work
If you
exactly and
can
as
explain
precisely as
the
you
whole
wanted to.
thing again, I'll stop sharing it.
Okay.
I saw a solution for this in a binary search way, and like, I'm not getting into it. So I'll share my screen so that you can
Yes, sure.
see. Yeah. So, so this is one binary search approach. Like if you want to read it out, you can. Okay. Anyone who got the like solution? I'm not getting this part. Like, if why are we changing? Anyone who would like to explain this?
I just understand that how it is saying that like if our the count is less than k, then it
Yeah,
then our
I'm
range
also not
would be,
getting this.
yeah,
Okay.
like how many counts, like the count here means like um, the fraction which we reached, like number of fractions which we reached, and if it is less than k, uh, then we need to move forward because our k is great, k is more and our count is still less, so we need to take the range of middle to high. But if our fractions are if our count is greater than the k, then it means that our answers lies between the low and the middle.
Okay.
This is what it is saying. The number of fractions below middle. Yeah. Here
Can you
the
put it
thing is we
further?
need to count how many fractions have been done, is one of the thing. How many fractions we have created.
The time complexity will be like unlocked.
W is the width for binary search.
Okay, so I guess it will be much faster than the heap approach because we are traversing, like we are getting all the pairs that we could have. But in this, like this is the more efficient way.
Mhm. So what I was thinking is like we here the main thing is like how we are creating number of fractions in that particular range. So if
Yeah.
we,
So you got like how many fractions you can create, but here it's like it's just checking with the value of k only.
yeah, so that's why it is like how we are making a binary search over here, like how we are like changing our high and low
Yeah.
by checking if the fractions are number of fractions which we have created is less than the k, then we need to have more fractions, so our range should be between middle to high. Like middle is like when we get middle between 0 to 1, the middle is zero point 0.5. Our range could be by zero point 0.5 to high, which is 1. And then we need to get more some cases. But if it is already less than like if our fractions is greater than the k, then our range is lies between that the low to the middle, and our answer should be in that interval. And if it doesn't have, if it is equal, then which means that our answer is we reach the answer of that, and middle is our answer, then which means,
Yeah. So
yeah, it's
okay,
somewhere.
low in 0.0, 1.0, then
Mm,
okay, fine. So it makes sense now.
mhm.
Like I'm still not able to visualize it like properly, but I have to use some pen paper to visualize it.
If I let me see. like I want to code it, but in my way, not like this way. So it's more into that.
Okay. So anyone who have any questions, approach, anything? Like I still don't know, like I can't visualize this binary search approach, but yeah, I will look for it after the session ends. Okay, so I guess we shall wrap up, and anyone who wants to discuss something, fine. So thanks everyone for like having a great session.
Thank you, and I look forward for this question.
Yeah, me too. Okay,
Okay.
bye bye everyone.